welcome to GDC Classes English. So we are back with our Target Pharma series where we are going to cover the MCQs of the drug absorption process. Now this being a part of the biopharmaceutics, we all have earlier covered about the 25 classes or 50 classes series. If you have watched it, go. If you have not watched it, please go and watch it. Otherwise, this series will be very beneficial for you all, where I am going to cover the MCQs of the topics as well as the explanation topics are also going on. So just now we have completed the MCQs of the physical pharmacy, and I hope you all have seen the videos. If not, you are preparing for any GPAT, NIPER, DI, any pharmacist exam you are preparing for, this is one short platform which is going to provide you the designed videos in your syllabus format. So please make sure to watch the explanation videos, cover the MCQs, and try to be as active as possible. You can leave your feedbacks. We take it very seriously. Any doubts, any queries, we highly welcome you all in this platform. Make sure to watch this video completely. You can subscribe and like the channel as well. So let's start with our first question of the day. So question says, drug absorption is defined as what? This is a very simple question. So is it the movement of drug from the bloodstream to the site of action? Is it so? No. The process of metabolism of the drug in the liver, that itself will be metabolism. The process of movement of unchanged drug from the site of administration to the systemic circulation. Now that is what we call it as drug absorption process, from the site of the administration to the systemic circulation. So we have our correct answer as option number C. Okay, moving on to our next question. So this was the drug absorption. We have, what should be the ideal solubility of an orally administered drug in the pH of around 2 to 8? Now this is a very broad question. Generally such questions I think are not entertained, but still you must have the idea about it. So we have the correct answer around 1 to 2 milligram per ml, right? So considering the pH range, the solubility of the drug has to be around 1 to 2 mg per ml in the pH range of 2 to 8. Okay. Next, which of the following statement describes the fixed law of first law of the diffusion? So we all know in the diffusion process, whereby we have the concentration gradient that is developed. Now that concentration gradient actually causes the movement of the drug from the higher to the lower concentration, right? Now that diffusion, that passive diffusion is very much described by this fixed law, right? So does it says the rate of diffusion is inversely proportional to the concentration gradient across the membrane. Just I have mentioned along the concentration gradient from high to low concentration. That can be concentration gradient or even the electrochemical gradient. The drug molecule diffuse from a region of lower concentration to higher concentration. No, higher to lower is it? Lower to higher, that will be against the concentration. The rate of diffusion directly proportional to the concentration gradient across the membrane, or the diffusion occurs regardless of the concentration gradient? No. I hope you have got your correct answer. That is the rate of diffusion that is proportional to the concentration of the drug from a region of higher to a region of lower concentration. Now that is being guarded by our fixed law of diffusion. You can already spot this will be dq by dt, that will be the rate of the drug diffusion. D will be the diffusion coefficient. Then we have our surface area. Then we have partition coefficient upon the height. And here we have differences of the concentration, right? Next, according to fixed law of diffusion, the rate of diffusion is directly proportional to, just we have seen rate of diffusion is directly proportional to the concentration gradient, right? Based on its equation, we have just seen here option B will be correct. Next, which of the following mechanism is defined as the difference in the drug concentration on either side of the membrane? So just we have seen in the diffusion process from a region of higher concentration to a region of lower concentration, unless the equilibrium is maintained, then it is termed as the diffusion process. Around 90% of the drugs do pass through with the passive diffusion process, right? So we have passive diffusion whereby the difference in the concentration is actually present, that is guiding, that is the driving force, that concentration gradient is the driving force. Next, passive diffusion follows which order of kinetics? So passive diffusion or any ADME process, generally if it is not saturable, that means any carrier system or any enzymes are not involved, not any capacity limited process. So it is a non-selective and first order kinetics, right? Even if there is a saturable process, then we could have mentioned the zero order kinetics or mixed order kinetics to be precise. Okay, next. Which among the following process causes for the responsible for more than 90% of the drug absorption process? Now I have mentioned right before this that passive diffusion, around 90% of the drugs actually follow their passive diffusion path for their transportation across the membrane, right? So that will be causing the concentration gradient to develop and so as cause the transport of the drugs. So we have our correct answer, option number D. Okay, next. What is the driving force? See, just now I have mentioned driving force is concentration gradient or electrochemical gradient. So, is it the concentration gradient only? No. Is it the electrochemical gradient only? No. Charge equilibrium and concentration gradient? No. Concentration and electrochemical gradient both. Just before this I have already mentioned this, right? We have option D as correct. Next. Passive diffusion. Passive diffusion follows which type of kinetics? We have seen passive diffusion before this. Also, the same question was asked. It follows the first order kinetics. I hope you all are able to answer the questions. The explanation is repeated. The questions are from the repetitive content. Just for your sake, let's revise it quickly. So passive diffusion, here the concentration gradient has a major role. From a region of high to a region of low concentration, the transport is happening, for responsible for around 90% of the drugs, follows the fixed law of diffusion. This is non-ionic diffusion, follows first order. Zero order if it is, it should be saturable, but it is first order, it's a non-saturable transport, right? It follows first order kinetics. Now the drugs which are in the range of 100 to 400 Dalton of molecular weight, they are readily able to passively diffuse. So the drug must be lipophilic as well as around 100 to 400 Dalton to be able to easily pass across. However, certain hydrophilic molecules which are less than around 100 Dalton, they are also able to cross through the passive diffusion transport. Now, this is the reason we call it as non-selective, because both hydrophilic and lipophilic molecules, although we have a limitation of the size, are able to pass. Okay, next. The ease with which a drug can penetrate or diffuse through a membrane, that will be termed as permeability, biotransformation, diffusion or filtration. Now here most of students will get confused between permeability and diffusion, I suppose. Filtration is yet another thing. Biotransformation is a chemical conversion or metabolism. So here ease with which the drug can penetrate or diffuse. So it's a term which is causing the drug to diffuse, that will be the permeability or the ability of the drug to actually pass through the membrane. Okay. Next, which kind of the molecules cannot pass through a pore transport? Just now, whatever questions in the drug absorption process we have covered, they were somewhere of the part of the passive diffusion process. Now we have the pore transport process. Let's learn a few things about it and then we can focus on it. So pore transport, as the name suggests, pore. So here we have certain aqueous pores or channels in the membrane, or we can say a very limited hydrophilic space that is present in the membrane through which the drugs can actually pass. So in the pore transport, only drugs which are very low in molecular weight, just I have mentioned, 100 to 400 was in the passive diffusion. 100 or less, that they are able to pass, but they must be hydrophilic in nature. So in the pore transport, there is a solvent drag, the water flux is created because of the hydrostatic pressure. So that governs it as a driving force, that water flux or the solvent drag that will bring the hydrophilic molecules, and that with the pressure it will be able to pass across this pores, right? So the drug must be very much less than the 100 Dalton. So low molecular weight drug can pass, water soluble it must be, and up to 400 Dalton. But if it is more than 400 Dalton, then it makes it very much impossible. However, it must write 100 Daltons for a more precise response. Okay, next. Now that pore transport is also known as the convective transport, or we have seen the bulk flow. What is the driving force of the pore transport? Just I have mentioned the solvent drag, the water flux, the hydrostatic pressure that will cause the transport of the drug. Concentration or electrochemical gradient, that is for the passive diffusion. So we have option A as our correct answer. Okay. Okay. Next. Which of the following is the best description of the ion pair transport? Now we have seen the passive, we have seen the pore transport. In the ion pair, as the name suggests, ion pair transport. So there must be an ion and there must be a counter ion that is present, which is forming a conjugate, because the ion as such is not able to pass across the membrane. So neutral complex is generally made. That complex is made to pass across, and that once it is crossing the membrane, then it will leave the counter ion and the drug is now available, transported. So let's see, it forms a neutral complex with the both required lipophilicity as well as aqueous solubility for the passive diffusion, quite considerable. It is a process where drugs are absorbed exclusively through active transport mechanism. No, it can be in passive as well. Occurs only for drugs which have high partition oil and water partition coefficient. No, the process involves ionization of drugs at all pH, preventing their absorption. Not at all. Just I mentioned, a counter ion must be present that forms a neutral complex through which drug is actually transported, right? So we have our correct answer as option number A. So this is our ion pair transport. Next, which of the following gets absorbed by the ion pair transport? Drugs which are highly lipophilic. Oil droplets, generally they go through the endocytosis process. Affinity for the carriers, or drugs that ionize at all pH conditions. So generally the drugs which do ionize at all pH conditions, they require a counter ion to be transported, right? Generally unionized drugs are easily absorbed, but it will even if we try to send it, we need a particular counter ion. What will be the best definition of a carrier? So generally carrier is something that carries the drug, right? Which is the drug which is itself having some limitations of its own inherent limitations, that carries the drug in a baggage that takes it to a particular target. So the non-polar drugs can be transported through carrier-mediated transport. Carriers reversibly bind and non-covalently with the molecules, discharges the molecule and destroys itself. Carrier is a protein. No, generally the carriers, obviously they are carrying the drug and carrying the drug to their own target. So they do carry it reversibly, non-covalently, because if there was a covalent bonding, they must not be able to release the drug when it is required. Okay. Next, which of the transport is best suited for your carrier mediated transport? Now before that, carrier mediated transport, that requires a certain carrier that binds with a drug. That binding must be reversible, just like the counter ion binding in the ion pair transport, that transports the drug across the membrane and the carrier is now free to go. But one thing must be noted here. The carriers are very much limited in number. So we have limited number of carriers which are binding to the different drugs, right? So that binding with a carrier, that we can term it as a saturable transport. Why? Because the carriers are limited in number. We have a capacity limited process which is going on. So even if the drug binds to a particular carrier, that will actually be the that will form a non-linear, or we can say the saturation condition has arisen, which gives the condition of the non-linearity. Okay, so that carrier mediated transport affects only for the lipophilic drugs with high partition coefficient. Not at all. Polar drugs which are such as monosaccharides, amino acids, can cross the membrane more easily with the specialized transports. Carrier mediated transport occur in the presence or the higher concentration of the drug, or it is irrelevant for the absorption of the water soluble drugs. So the most suitable answer will be option number B. Generally your vitamins are actually able to transport with this carrier mediated transport easily. Okay, next question. Now you have to match the column A with the column B. Here we have column A with the suitable description with the column B. Okay, let's see. Passive diffusion, drugs that ionize at all pH conditions. So this ionization we can deal with the ion pair transport. Macromolecular nutrients and drugs at solid particles or oily droplets. I have just mentioned they may, and oily droplets use the endocytosis process. Water soluble drugs of molecular weight less than 100. Hydrophilic less than 100, pore transport, water flux, solvent RAG is created. Drug having high lipophilicity range 100 to 400 Dalton molecular weight will be the passive diffusion process. So repetitively you can see the words, you can see the same things are being repeated in every question, and so is this you will spot in your exam that the questions are asked like this only, right? So you must emphasize on what is being told. So I think you got the correct answer, option number B. Okay. Okay, next. Which kind of drugs are absorbed through endocytosis? We have just seen higher molecular weight, oily droplets, macromolecules. They are only transported via endocytosis process. Repeatedly, I am saying the same thing. Okay. Which of the following absorption method involves engulfing of the extracellular drug? Now, ion pair usually complexes with the counter ion. Facilitated diffusion facilitates, just like in the carrier mediated, it is another your downhill transport mechanism. Then we have here also the concentration gradient is developed. In the passive diffusion also concentration gradient is developed. In the endocytosis we have engulfing, or just like in amoeba you have seen how it engulfs the food. So oily molecules, macromolecules, they are engulfed and then transported. So we have endocytosis. Okay. Now moving on to our last question of the day. In which of the following process drug is absorbed into the lymphatic circulation, thereby bypassing the first pass metabolism? So drug is actually being absorbed into the lymphatic circulation and then bypasses the hepatic metabolism. Now that is going to be our endocytosis process, right? So let's quickly see the explanation. We have endocytosis that is responsible for the uptake of the oil soluble vitamins A, D, E and K, right? And then such process absorbs the drug into the lymphatic circulation, okay, bypassing the first pass metabolism. So that's it for today. I hope you have answered the questions correctly, and I will check the comment section. Please comment down how much you have scored in any question or any other topic you would like us to add into the videos. We would highly appreciate your feedbacks. Thank you so much. That's it for today. We will meet in the next video.